For decades, global conflicts were fought over oil, land, and borders, but a new race has already begun in the darkest parts of our oceans. Powerful nations are now sending advanced machines miles beneath the surface, searching for something worth trillions of dollars. Hidden across the ocean floor is a resource that could power the global economy for decades. And the next great resource war may not happen on land. It may begin 4 miles beneath the sea. Far below the ocean's surface lies a landscape few humans have ever seen, the abyssal plains. These enormous stretches of the seafloor cover vast areas of the planet. They are cold, dark, and silent. Sunlight never reaches these depths, and the pressure is strong enough to crush most equipment designed for land. At first glance, the abyssal plains appear empty, but scattered across this underwater desert are small black metallic stones that may become some of the most valuable resources on Earth. In 2026, global demand for critical minerals like cobalt and nickel has exploded. The reason is simple. The world is rapidly transitioning to electric technology. Next-generation solid-state batteries promise faster charging, longer lifespans, and far greater energy capacity than traditional lithium-ion systems. These batteries are expected to power electric vehicles, renewable energy storage, and the next generation of electronics. But building these technologies requires enormous amounts of specific metals. And increasingly, the world is discovering that the largest untapped supply may not be on land. It may be on the ocean floor. Across parts of the Pacific Ocean, the seabed is covered with what scientists call polymetallic nodules. These rock-like formations grow extremely slowly over millions of years as layers of dissolved metals accumulate around tiny fragments on the seabed. Over time, these particles form dense metallic nodules rich in cobalt, nickel, manganese, and copper. In some areas, millions of them lie scattered across the seabed, and the scale of these deposits is staggering. Some estimates suggest the ocean floor could contain more of these critical minerals than all currently known land-based reserves combined. As traditional mining becomes more expensive and politically difficult, attention is rapidly shifting toward the deep ocean. What was once considered unreachable territory is now becoming the next frontier of resource extraction, and that frontier is already triggering global competition. As the value of seabed minerals becomes clear, the oceans are quietly turning into a new geopolitical battlefield. Under international maritime law, countries control exclusive economic zones that extend roughly 200 nautical miles from their coastlines. Within these zones, nations have the right to exploit natural resources found in the water and on the seabed. But beyond those zones lie vast areas of international waters, and those areas are now becoming the focus of a growing global contest. By 2026, several major powers have begun mapping potential mining zones across the Pacific and Indian Oceans. Exploration permits are being issued, research missions are expanding, and governments are positioning themselves for future extraction rights. This has created a quiet but serious geopolitical divide. Western alliances and countries within the BRICS bloc are both competing for influence over deep-sea mining regulations and permits. Each exploration license represents potential access to enormous mineral reserves, and each new claim increases the strategic importance of the seabed. In the 20th century, oil fields shaped global power. Energy dominance determined alliances, conflicts, and economic influence. Now a similar shift may be happening again, but this time the resource is not oil. It is the metals required to power an electrified world. And instead of pipelines and drilling rigs, the new infrastructure of power may lie thousands of meters beneath the ocean surface. Reaching the seabed is difficult, mining it is even harder. At depths approaching 4 miles below the surface, the ocean becomes one of the most hostile environments on Earth. The pressure is crushing, temperatures hover just above freezing, and sunlight never reaches the seafloor. Traditional mining equipment cannot survive under these conditions, so engineers are building an entirely new generation of machines. Autonomous seafloor crawlers, robotic collectors designed to move slowly across the seabed, gather polymetallic nodules and feed them into massive collection systems. These machines must operate for long periods while enduring extreme pressure and navigating uneven terrain. Once collected, the nodules are transported through enormous vertical pipes known as riser systems. These pipes carry the material thousands of meters upward to specialized ships waiting on the surface. Even then, the process is far from finished. The extracted ore must still be processed, transported across oceans, and integrated into global manufacturing supply chains. The technological and logistical challenges are enormous, but so are the potential rewards. The first nation to develop efficient deep-sea mining technology could gain a massive advantage in the global supply chain for critical minerals. And in an economy increasingly powered by batteries and electrification, that advantage could reshape global industry. But this race for seabed resources comes with serious risks. The deep ocean remains one of the least explored ecosystems on Earth. Scientists estimate that many species living in these depths have never been discovered. Some may exist nowhere else on the planet. Polymetallic nodules themselves often serve as habitats for marine organisms. Removing them could destroy ecosystems that took millions of years to develop. Another major concern is the creation of sediment plumes. When mining machines disturb the seabed, clouds of fine particles are released into the water. Ocean currents could carry these plumes far beyond the mining site. Some scientists fear they could travel thousands of miles, potentially disrupting marine food chains and global fisheries. This creates a difficult dilemma. The minerals found in these nodules are essential for technologies designed to reduce carbon emissions, but extracting them could damage ecosystems we barely understand. And the long-term consequences remain uncertain. As the race for seabed minerals intensifies, international law is beginning to change. Maritime regulations originally designed to manage shipping and fishing must now address the possibility of large-scale industrial activity on the ocean floor. Countries are preparing legal frameworks, research programs, and monitoring systems to secure potential mining zones. Some analysts believe disputes over these underwater resources could eventually trigger geopolitical tensions. Control of deep-sea mineral supply chains may become a central element of national security. For many nations, securing access to these resources could mean technological independence. Others may see it as a strategic vulnerability. Either way, the world is entering a new phase of resource competition, because the next great global struggle may not be fought over land. It may unfold in the silent darkness of the ocean floor, and the race to control it has already begun.